Right, hello and welcome back. Congratulations, we have now our application deployed using Docker, and we used the latest microservices-based architecture for that. However, the way we built our application has its own drawbacks. Some of them are going to be addressed in this section, some others are going to be addressed later. But before we go to the drawbacks of our architecture, let's address one question that might have popped in your head when we were deploying our application. Why we used the IP address that we used. When deploying our web server image, we said that it's going to talk to 172.17.0.1 at port 3000. That was the application server. And on the application server, when we wanted to instruct it to talk to the database, we ordered it to connect to 172.17.0.1 also. Of course, we are using here the MongoDB protocol, so by default it is going to connect to the MongoDB port, which is 27017, and it's going to work with a database that is called, or a schema that is called posts. But what is this magical IP address? What is so special about this IP address? This is the router for Docker. This is like the NAT IP address of Docker. If you have worked with NAT before, Network Address Translation, the NAT device has one external IP address, and behind these IP addresses are other private IP addresses that are not visible to the outside world. In order to access those IP addresses, the NAT device has to do something called port forwarding. So, for example, if I want to talk to the web server on port 80, I will have to go to port 8080. That is what we did when we created the container, when we passed in the -p, and we instructed Docker to pass in any requests that are coming at port 8080 to port 80. That is called port forwarding, and that is handled by the gateway or the router of Docker. This router is placed at 172.17.0.1 by default. This is a default IP addresses that comes with Docker when it is installed. So how to know which service I will need to connect to? Simply, you pass in the port of the service. So here we were using the port 27017. Here in Eduonix, we used port 3000 to connect to the application server. So this is one way by letting containers talk to each other. Later on in this class, we're going to see other ways of communication between containers. Okay, back to our main topic of this lecture, the drawbacks of our architecture. First, MongoDB has no authentication. If you remember, when we connected to MongoDB, we did not pass any credentials. We did not pass a username or a password. If you are used to working with databases like Oracle or MySQL, for example, you know that every database and every schema must have a user, or at least there is the administrator of the database, of which we need to supply the credentials in order to be able to access the database. But with MongoDB, we just connected to it without passing any credentials. Of course, this is a major security flaw, and that is the default installation of MongoDB. It allows anybody to connect to it without using a user and a password, as long as the connection is coming from localhost. And of course, due to the architecture that we have just talked about, we are connecting to MongoDB as if the connection is coming from localhost because it is behind a NAT device. So the connection is received by MongoDB as if it is coming from its own IP address, from its loopback IP address. So we were able to access it, and we were able to execute commands against it. But this needs to be fixed. The second thing is that the database data is stored inside the container itself. If the container is destroyed, the data is lost. So let's see that in action. Now we are in the terminal. Let's run docker container ls. We have now our database db01. And because we passed in the --rm when we created that container, if we type docker stop or docker container stop db01, it's going to be deleted. Now, if we try to create that container again like this, and we go to the browser and refresh the page, you're going to see that everything is gone. The post that we have created is no longer available. That is because we have destroyed the container and created it again. Doing so effectively deleted any data that was inside the container. So that is another drawback that needs to be addressed. Third, we had to hard code the IP addresses of the database and application servers. We used, as I have just mentioned, we used the gateway IP address of Docker or the NAT IP address of Docker. That is not a good practice. There needs to be other ways for Docker containers to discover each other and to be able to connect to each other automatically without having to hard code their IP addresses inside configuration files. Next, the application server will fail to start if the database is not already running. So if I stop the database, the application is not going to run. That is because node.js connects to the database automatically when it starts using Mongoose. So we need to find some way for node.js to defer loading or to give an error message that the database is not yet up and running, instead of just failing. The authentication mechanism is part of the image. We have hard-coded the username and the password inside the image itself. That is another security flaw, because anybody with access to the history of the image, like for example, if I type docker history web01, docker history web for the image, I'm gonna see the commands that were used to start this image, including the arguments that I have passed. So as you can see here, I have arg password equals pass. That was inside the file, and I also have password equals pass123, so I have both passwords, the default one and the one that I have entered during the image build. So this makes any user with access to the image have an idea about the password, which is a major security flaw. Finally, authentication is done over HTTP. Anybody who has access to the network and can sniff the data packets that are passing between your browser and the container will be able to effectively sniff the password, because it will be sent in clear text. So this makes the whole point of authentication useless. You have to send the password over an encrypted medium, so you have to use secure HTTP or HTTPS for communication between your browser and the container. In this particular section, we are going to address just two of those drawbacks, which is the second and the fifth. So let's get to our terminal, clear the screen. Now, the second drawback stated that the database data is stored within the container. Docker has a method of letting you store the data of the container outside the container or on the Docker host itself. This is called volumes. Docker volumes are of two types. You can either store them automatically in some location managed by Docker. This is called named volumes, or you can specify your own path, your own file path for Docker to save whatever data you need from the container to that path. So in this particular case, we are going to use named paths. So the first thing we're going to do is that we are going to stop the containers. So docker container stop db01. Okay, now all the data inside the container is lost. Now I'm going to run the same container, but with a slight modification. Let's just get to the command again. I'm just going to add here, right before the image, -v for volume. And I'm going to type db data. This is the name that I have chosen to the volume. Hence the name, named volumes. So db_data is the name of my volume, and it is going to mirror whatever is in /data/db. This tells Docker to map anything that is inside /data/db inside the container, which is the data that is stored by MongoDB, the location where MongoDB uses to store data. It's going to be saved in a named volume managed by Docker that I have chosen db_data for its name. Now, if I press enter, the container now is running. But notice here what happens when I type a command like this: docker volume db_data, or docker volume inspect db_data. Now you have an idea about the location, the physical location of this named volume on the system. It's in /var/lib/docker/volumes/db_data/_data. Okay, so now let's refresh the page and let's make a new post again, just to save the data. Title, persistent data. Subtitle, this data will persist. Okay, so that is my post. Let's save it. Okay, let's start the app. It was not started. Okay, now let's save this post. Okay, let's go to home, ensure that this post exists. Okay, persistent data. Okay, now let's go to the terminal and let's run docker container stop db01. Okay, now the container is stopped and it's also destroyed. So if I run docker container ls even -a, you only have app and web. DB is no longer available. You go to the browser and refresh the page here, just an empty page. If you go to the home page, there is nothing here, because of course the database is down. Now let's start that container back, ensuring that the volume is mounted. The named volume is mounted. Okay, now it is running. If we refresh the page, okay, and we need to start the app because it fell into a problem when we tried to access the database and it is down. So let's start it. As you can see here, we have the post. The data will persist. this data will persist, and actually it did persist, although the container was destroyed and recreated again. So that is one way that Docker can save volumes on your host. Now let's have a look at our next drawback in this section, which is that the password was saved inside the image itself, and even when we used an argument that was passed during the build command, it was visible to anybody who could use the Docker history image. One way of working around this is keeping that file locally on our Docker host. So we are going to use Docker volumes for that, but we are going to use a local volume with a local path. We won't let Docker manage this path for us. We are going to specify it for ourselves. So the first thing we need to do is create a .htpassstability file locally on our system. To do this, we are going to run the same command that we have run before on our image, but this time it's going to be here. So user Bob, again, OpenSSL. Just want to make sure that OpenSSL is installed on my machine. Okay, it is installed. So printf Bob OpenSSL pass wd-1 pass 123. Let's change that to be my pass, for example, for a change, \n for a new line, and add this to a file on my home that is going to be called my htpasswd. Just a file. Okay, now if I cat my htpasswd, I find that we have a user Bob and the encrypted password, which is my pass. We need this file to be available for the volume when it starts. So let's go to Docker container stop web01. Now it is stopped and deleted because we used the --rm during the container run command. Now let's run that again, but this time we're going to add -v as usual for the volume, and we are not going to use a named path. We're going to use home for the home, which is the tilde. If you are asking, the tilde here is for home. This automatically refers to the home directory of the current user. Same thing holds for $home, my htpasswd. As you can see here, it had bash automatically substituted the path for my home directory, then colon, and the location where I want this file to be mapped to, which is /usr /share /www/html. Of course, .htpasswd file. So now I'm effectively changing the htpasswd file that was created by the image with the one that I have created on my local machine. This one. So even if the user had access to the Docker history image command and was able to verify the password that was used inside the file, whether it was the default one or the one that was passed through the arguments, he or she will still not have access to the restricted part of the website because I have used a different htpasswd file. I've used a local one and mapped it to the remote one on the container. Let's press enter. Now go here, refresh the page, go to create. This is the cached version. If I refresh, I'm going to be presented with the authentication. If I type Bob and the old password, pass123. Okay, permission is denied, restricted content. If I type Bob and the password that I have just added, which is my pass, now I have access to create new posts. That brings us to the end of this lecture and to the end of this section. In this section we did a lot. We were able to create an application stack based on the latest microservices architecture. Using Docker containers, it was very, very easy to deploy this application. It was very easy to make changes to each and every component of the application. I hope you enjoyed this section and see you later.